learned the concept of limits of a function when the variable x approaches c. Let's now look at some special examples. So let's call them basic limits because they are like especially easy functions. Remember, when we talk about limits, we always want to have the what and the where. And in case 1 here, we have a constant function. So I say the limit of b as x approaches c. So what does that mean? That means in the what part, I'm taking the limit of a constant function. Okay? And you can see that if I graph this, let's say b is this value, then for any point x, I have the same output value b, right? Okay, so now let me pick any arbitrary point and say this is the c. As you can see on the graph, when doesn't matter where c is, as you always have the f value equals exactly b. So when we take the limit of a constant, doesn't matter which constant it is, when we take the limit of a constant, doesn't matter where the c is, we always have the same constant b there. Okay, example. Let's say if I'd like to take the limit of 2 as x approach 1. So now I have the b equals 2, right? And the c is equal to 1. So on the graph, you can see that when x approaches 1, we have the output value same as 2. So this is 2. Okay. So now keep in mind, first basic limit result is whenever we take a limit of a constant function, or whenever we take a limit of a constant, doesn't matter where the c is, the answer is always the same constant b. Second example, we have a monomial. Basically, you can think this is a polynomial, x to the power n. So let me give an example. Suppose I have the limit of x to the power 3. So this is the case n equals 3. So here I'm saying that for any general n here, okay, let me pick a number. Let's say 3. Too many threes. Let's do 2. Okay. So a polynomial is a continuous function. We'll discuss continuous function later, but it's like, it goes like a whole graph, okay? And a very important property about continuous function is, see, so over here, then when we take the limit, let x approach c, you can see the limiting value would be the same as the function value at c. So what does that mean? That means in this example, I have f of x. So let's compare this example with the general form. We have f of x being the function x to the power n. This is given, okay? And the limit equals f of c, the function value. What is f? F is x to the power n, so this is c to the power n. So whenever we have a polynomial or a monomial like this, when we take the limit, we simply plug c into the function, okay? So I can ignore the f part because I just made this up. So this is c to the power n. Okay, so let's go to this concrete example. Compare the format x to the power 3, so it's the same format as x to the power n with n given as number 3, and c is the number 2. Okay, according to the rule we learned, what is this? We simply plug 2 into the x, so this is a 2 to the power 3, which is equal to 8. Okay, let's do one more. If I have the limit of x to the power 4 and let x approach, I don't know, let's say 3. So what do we have? We will simply plug 3 into the x. So this is 3 to the power 4. Okay, so 3 times 3 times 3 times 3. Okay, so this is 9, 9 times 3, 27, 27 times 3, that's 81. So 81 is the limiting value.